As you know, and we already discussed in electrical circuit 2, we will talk about alternating circuit sources and AC systems. We will have circuits including capacitor and inductor and alternating voltage and current sources, and we will apply the same methods that we learned for DC circuits on AC circuits. Okay, but as I mentioned, today we are going to go over the assignments. Engineering 224, week 1 assignment, problem number 1. Sketch the following exponential waveforms. Find the amplitude and time constant of each waveform. So we have two waveforms. V1 of t is equal to 50 e to the power of negative 100 t u of t v. We want to sketch this signal. Okay, what is the amplitude? The amplitude of this signal is 50. So VA is equal to 50. And the next information we have is this negative 100, which is time constant. Tau or TC is equal to 1 over 100, because in general we know that the form of exponential circuit, exponential waveforms, is VA e to the negative t over TC or tau. Okay, so 100 is 1 over tau. So time constant will be equal to 10 milliseconds. Any question? And now we need to sketch the waveform. If here is time per second and here is V1 of t, of course we know after 5 tau we are going to almost reach to 99% of the stable situation. So we consider 5 tau, which is 50 milliseconds. So ten milliseconds, 20 milliseconds, 30 milliseconds, 40 milliseconds, 50 milliseconds. Okay, so here is 50 milliseconds, and the maximum amplitude is 50 volt. Let's say here is 50 volt, here is 25 volt. So at t equal to 0, we know that this term is equal to 1. E to the power of 0 is 1. So we will have 50 times 1, which is equal to 50. So the signal starts from this point. And at 5t, it reaches to the almost 0. So we sketch the waveform. It is the waveform. Any question? Okay, the next part, before moving to the part B, before moving to the part B, I want to have another like part for this question. Let's say we have A2. We want to sketch the waveform for this signal. 50 e to the negative 100t u of t minus 0.02. So we want to sketch this waveform. This is not part of your assignment, okay? Just I add it now. If we look to this waveform and compare it with the other waveform, everything is same. So this part is exactly same as this part. The only difference is in the u of t. One of them has u of t. The other one has u of t minus 0.02. First, let's plot u of t. U of t, of course, this one is u of t. This one is u of t. Okay, it starts from 0 and the magnitude is 1. So if we multiply this u of t by this signal, anything after 0 in our circuit, anything after 0 will be part of our signal. Anything after 0 will be part of our signal. Because before the 0, u of t is equal to 0. Anything before of 0 will be 0 because 0 times any value is equal to 0. But after time 0, because u of t is 1, the signal will be shown as is. Okay? So this one is u of t. But what if instead of u of t, we have u of t minus 0.02? If we plot u of t minus 0.02, we will have this waveform. We will have this signal. If here is 0.02, this is the signal. Anything before 0.02 is 0, and after 0.02, u of t minus 0.02 is 1. Is it clear? Okay. So if we multiply this u of t, which is here, if we multiply this u of t by this signal, what's gonna happen? Anything before 0.02, anything before 0.02 will be multiplied by 0 because u of t is 0. So this part will be 0. Anything after 0.02 will be remain. So if we plot this signal, we will have this waveform. The signal originally was this signal, but what we will have is only this part of the signal, and before it is equal to 0. Okay, so this one will be the signal. Is it clear? So anything before 0.02 has been multiplied by u of t minus 0 2, which is 0 for time less than 0.02. Okay, so how we can find, let me just divide again, it's not how we can find this v, what this amplitude. Do you have any idea how we can find this amplitude? Just think about it for like few seconds and let me know if you have any idea. We know that if we extend the curve until t0, we cross the vertical axis at 50. But what is the maximum point here? Any idea? What is t here? T is equal to 0.02. Okay, it's easy. The only thing we need to do, substitute 0.02 in this equation. Instead of t, we put 0.02. So the amplitude v will be equal to 50 e to the power of negative 2 u of t minus, because t is 0.02, so it's times 1. So v is 50 e to the power of negative 2. Okay, so that's it. So this one is the answer. Okay, very good. So it's 6.76. Perfect. So v is equal to 6.76. That's it. Okay, so we got the answer. Any question? Okay. Now let's move to part B. Part B, we have another signal. V2 of t is equal to 5 e to the power of negative t minus 5 u of t minus 5. Okay, if we look to this waveform, of course we have u of t minus 5, so it means that everything before 5 is equal to 0. Okay, but what about this part, this exponential power? Because the time in both exponential function and u of t are shifted by 5, it means that we will have our original signal shifted by 5. So it's not going to be cut. It's not going to be cut like what we saw here. Here the signal was cut. Part of the signal was cut, but if the exponential also shifted, with the u of t, the entire signal will be shifted to the right or left. Okay, it's not going to be cut. Let's just see that one. The first thing is finding tau, or time constant. Or tau is equal to 1. Here is equal to 1. Okay, because it's negative t over tau, and tau is 1. 5 tau, of course, is 5, and we have shift, 5-second shift. Okay, so let's plot the circuit. Okay, what is the maximum value of the signal is 5. So let's say here is the maximum value of the signal. Okay, and the signal has its maximum at a start point which is 5 seconds, okay, because it's t minus 5, maximum value at t equal to 5, because in the exponential function we have 5. So at 5 we go up, and here is the start point of our signal. The start point of our signal. How many seconds it takes to reach to 0? 5 seconds. So after 5, we need 5 seconds to reach to 0. So at 10, we will reach to 0, and here is the signal. Here is the signal. The signal is not cut, the maximum value is 5. Okay, the maximum value is the same as amplitude 5, but the signal, the entire signal has been shifted to the right by 5 seconds. But in our previous example, which we didn't have a time shift in the exponential function, we see that the signal was cut, and the maximum value of the signal was not VA, was 6.76. Is it clear? Any question? Okay. Problem number 2. Find the period, frequency, amplitude, time shift, phase angle of the following sinusoidal signals. So we want to find everything. So the signal is V of t is equal to negative 30 cosine of, is it 5,000 or 50k? 50,000. Okay. Pi t plus 40 sine of 5,000. Okay, we want to uh, find VA, okay, which is the addition of these two signals. We need to add these two signals because both of them have the same frequency. We can simply add them, okay. If the frequencies were different, we were not able to add those two signals. Okay, the first thing, one of them is cosine and the other one is sine. Both of them should be cosine format. Trigonometry. We know that sine of theta is equal to cosine of pi half minus theta, which is equal to cosine of theta minus pi half. Okay, so we should know this. Okay, it's a part of trigonometry rules. So we use this one to convert sine to cosine. So we rewrite the signal V of t is equal to negative 30 cosine of 50k pi t plus 40 cosine of 50k pi t minus pi half. Okay. How many degrees pi half? Who knows? Pi half is equal to how many degrees? Anyone?
90.
Yes, exactly. 90. Or we can say minus 90 degrees. Okay, so we have a rule that we learn. We will learn by like tomorrow the new lecture that I will post online. You will learn how to add these two signals by phasors, which is very easy, very easy. But for now, based on what we learned so far, let's use this rule that we had. We had cosine of a plus b was equal to cosine of a cosine of b minus sine of a sine of b. I hope it's correct. Okay, and we can use it to simplify our circuit. Okay, give me a minute. Okay, now we can say cosine of 50k pi t is equal to, because it's just simple, it doesn't have uh, it doesn't have two parts, any phase. It is equal to, it has a and b. a is a is negative 30 cosine of 0 degree. B is equal to 40 sine of 0 degree. For the other one, which is 40 cosine of 50k pi t minus 90 degree, A1 is equal to 40 of cosine of negative 90, and B1 is equal to 40 sine of negative 90. These values are equal to negative 30, equal to 0, it's equal to 0, it's equal to negative 40. So these are the values. We add them together. A3 is equal to A1 plus, oh, it's A2, B2. A1 plus A2 is equal to negative 30, and B3 is equal to B1 plus B2, which is negative 40. And now that we have these values, we can say VA, which is equal to square root of A3 square plus B3 square, which is equal to square root of negative 30 square plus negative 40 square is equal to 50, and phi is the phase angle is equal to arctangent of negative b, so b over a, which is equal to arctangent of equal to negative 126.87 degree. So the phase angle is negative 127.26. So and of course frequency is the same as our original signals, 550k pi. So we can say V of t, the output signal, is equal to 50 cosine of 50k pi t minus 126.87 degree. So this one is the signal. The frequency, of course, is the reciprocal of the period, and it's equal to omega over 2 pi. This part is omega, this is the omega, which is equal to 2 pi f, and f is equal to omega over 2 pi. So f it will be equal to 50k pi over 2 pi is equal to 25,000 hertz. T0 period is the reciprocal of the frequency, which is 1 over 25 kilohertz. It's equal to 40 microsecond, and that's it. Okay. So this one is the second problem of your homework. Any question? Okay. Problem
Uh,
number. Go ahead.
Professor, for the phi, the value you got after like taking the tan inverse of B and A, that's in degrees, right?
Say it again.
So the value you got for like the phi,
Okay.
tan inverse negative 40 by negative 30.
Yes.
Uh, that one when I put in my calculator, it gave me like 53.13.
Oh, yeah. That's a good question. Do you know what's the point? The point is here. If we look to our graph here, and it's like a plane, and we want to see what are sine and cosine of the signal. It's x, it's y, and if we have a circle here, we know that the, what was your number? What was your number?
So I get 53 something. Oh, so you subtracted from 180.
Exactly, 53 something. So the tangent of 53 something and tangent of 126 are same.
Oh, okay,
Both
okay.
of them are acceptable, you know, both of them are acceptable. Because if you look the tangent is this line, and if this is the like the angle theta, and it cross this line, this value is the tangent. Okay, this value is the tangent. So if it's theta, or it is like this theta, theta 1 and theta 2, both of them have the same tangent. So both of them are correct, you know.
Okay, got you, Professor.
Okay, so and it was very good question, Susan. Very good. Uh, the next Problem number 3, we have a waveform and we want to find the expression. Okay, we want to find the expression of this signal. We have some information. The first information we have, it's one period of this signal from one maximum to other maximum is 50 milliseconds. Because time is milliseconds, I said milliseconds. And that's it. We want to write the expression for this signal. How we can write the expression for this signal? Signal definitely is in the form of VA cosine of omega t minus phi or phi. So we need to find this information. Okay, we need to find the information. The first thing is the period of the signal. What is the period of the signal? Period of the signal, if we look to the picture, we see that the period of signal is 15 millisecond. Okay, the period of signal is 15 millisecond. So we say t0 is equal to 15 milliseconds, and as a result f0 is equal to 1 over t0, 1 over 15 milliseconds is equal to 66.67 hertz. Any question for this part? So from the figure, from this part, we got the frequency. The next information we need is about the phase. Okay, the cosine signal always starts from the maximum point, from the VA, the cosine signals. All okay, it starts from the maximum. But if we look here, we see that the signal starts from the minimum value, and it seems that the signal has like negative 180-degree shift. It was supposed to be started from this point, which is the maximum point, but it has negative 180-degree shift. How do I know it's 180 degree? Because from here to here, is half a period. It's half a period. One period is 360. We have half a period like shift, so we have 180. Okay, any question? So phi is negative 180 degree. Okay, so the next thing, any signal has a, like VA and negative VA should be same. So any signal has average of 0. Any cosine signal or sinusoidal signal has an average of 0. But if we look to this signal, we see that the maximum point is 4, the minimum point is negative 10. It means that the signal has been shifted to the down, Okay, how much is shifted down? Let's find it out, okay? So what is the V average of the signal? V average of the signal is 4 minus 10 divided by 2. I subtracted them and divided by 2. So the signal has been shifted by negative 3 volts to the down. The average of signal was supposed to be 0, but now it's negative 3. Now it's negative 3. And the next thing, what is the amplitude of the signal? What is the amplitude of the signal? VA. Of course, VA, we know that it is equal to maximum minus minimum divided by 2. The maximum is 4 minus minimum is negative 10 divided by 2. So it is 14 over 2 is equal to 7. So the VA, the amplitude of the signal is 7. How do I know that? The amplitude of the signal is VA minus VA divided by 2. So VA is 4. Negative VA is negative 10. So 4 minus 10, which is 14 divided by 2, which is 7. So VA is 7. And average of the signal should be 0. But here the average of signal we calculated is equal to negative 3. So it means that the signal has been shifted to the down by 3. So now using these informations, we can write the signal. The signal is equal to, the VA was 7 cosine of omega, okay, 2 pi f. What was f? F was times 66.67, 2 pi t minus 180. Okay, this one is the signal, but this signal has been shifted to the down by 3 points because the signal has been shifted. So we need to subtract it by 3 and multiply by u of t. So this one is the signal. So this negative 3 is the DC signal that has shifted the signal this way by 3 volts. Okay, so it's the DC voltage source with a value of negative 3 which shifted the signal. So this signal, let me just tell you in the other word, this signal was supposed to be something like this. Something like this. You see, 7, negative 7. But it's shifted down by 3 volts. So now it is something like this. It's a negative 10 and 4. So, and it's here. So we added negative 3 to our signal to shift the entire signal to the down. Is it clear? And so this one is the final answer. Of course, we can multiply 2 by 66, which is 133. Any question?
I have a question.
Go ahead.
So what I did was I did put the -3 instead of inside. I did u of t minus 3. So why is it on the inside instead of the outside?
T minus 3, you mean like something like cosine of 133 pi t minus 3?
No, on the outside, the u of t minus 3 instead of having the -3 on the inside of the brackets.
So you mean something like u of t minus 3. Like this?
U of t minus 3 in parentheses, t minus 3 in parentheses, like in an exponential form. Yeah.
This one?
Yes.
No, this one is not correct. This one, if you like, you write like this, the signal will be something like this. The signal was originally like this, but if we just put 3 here, what we will get, let's say here is 0.3. We can say the signal is cut from here, and we have a signal like this. But this 3 is not time shift. Whatever inside u of t, let me tell you, Esteban, whatever inside that u of t is considered as time shift the signal to the left and right. Is it clear? Shift the signal to the left and right. But here we see that the signal has been shifted like from top to the down, in the like voltage direction, not time direction. If the signal has been shifted in the time direction, you're right. You can say t minus u of t minus 3. But here the entire signal has been shifted in the voltage. When it's shifted in voltage, we cannot write it by time shift. We need to add a DC voltage, DC signal to shift the entire signal to the down or to the top. Okay, but as it's homework, that's code. That's fine. You will get the full points for your solution. There is no worries. But just in case for the next assignment, anytime you see there is a shift in time in the voltages, you cannot just apply it to the time. You should be considered as a separated voltage. Okay, any other question? Okay, very good. That's all for today.